All right, here we go. Last video on the rose curves. We're going to do an example where we graph cosine. And we're just going to move on in the notes. So we're going to do number 3. I believe that's where n is even. So here's an example of what we'll do. This one. All right. And then it doesn't have the x and the y-axis. But you can see n is even. So again, it's symmetric to the x-axis, y-axis, and the origin. And then in this case, n is 2. So you double that to get the petals. So we have 4 petals here. All right. If n was odd for cosine, then it would just be symmetric to the x-axis. All right. So let's go to number 3. All right. Number 3. All right. Let's zoom in here. So remember, first thing you always want to figure out is what is n. So n in this case is 2. So that tells us since n is even, we double n, and we're going to get 4 for the petals. Since n is even, it's going to be symmetric to both the y and the x-axis. So I'll put y and x-axis. And that'll give us shortcuts to get the 4 points for the 4 petals. And then when we rely on graphing the sine and cosine waves, period is, in this case, going to be 2 pi over 2, which is just pi. And then the increments, take the period divided by 4. All right. And just like the last one, the amplitude's 3. So the max is going to be 3. And I'll write it over here. So the max is 3. There's no vertical shifts, and you'll never have vertical shifts for the rose curves. The lessons that we do next week, you'll have vertical shifts, and you're going to get a completely different shape. But we're not going to look at that now. So equilibrium 0, minimum's -3. Now remember, when we graphed cosine started at the max or the min, and then since this is positive, this is where it's going to start. Right, cosine's going to start at the max. All right, so let's figure out theta. Right, we always start at 0. There's no horizontal shift. And then since the increments are pi over 4, all right, this is going to be a little bit better. The last one was really ugly with pi over 8. So we're just going to add pi over 4 to get the values for theta. So pi over 4, then we're going to get half a pi, then we get 3/4 of a pi, and then we're going to get pi. All right, and let's just leave it at that. All right, now this one right here, when you plug in 0, you start, it's cosine, so you start at the max. This is going to be 3. Okay, let's zoom out so we can see the r theta chart and then graph it. All right, so 0, 3. Here's 0, right? Go to the angle. And when we go to the third circle, it's this right here. Now that might be confusing because it looks like 3, 0. Well, remember, we're not dealing with x and y. We're dealing with r and theta. So that's where this point would be. Okay. Slide it over so you can see max, min, equilibrium. All right. So then we start at the max, and then we come back down to the equilibrium, which is 0. And if that radius is 0, well, then it's that point at the origin. All right. Then we go down to the minimum of -3. So pi over 2, -3. Right, here's pi over 2. But since r is negative, it flips 180 degrees to here. So it's going to be at 3 pi over 2, 3. So the third circle at 3 pi over 2 is going to be right here. All right, so I have 2 points. I just need to get 2 other ones. And let's see, actually, we probably can figure it out. If we draw it, let's draw these 2 petals. Man, my rose curves are horrendous. All right, now you have those 2. And we know it's symmetric. Let's use symmetry so I don't waste my time with this. It's symmetric to the y and the x-axis. So you can see this, it's already symmetric. This petal right here, it's symmetric to the x-axis. But if we fold this over the y-axis, you're going to get a point right here. So it's going to be at pi 3. So let's put that in there. Pi pi 3, 1, 2, 3. Okay, and then you can see that other point that we got here, this is already symmetric to the y-axis, but if you take this pedal and fold it over the x-axis, you're going to get this point right here at pi over 2, 3. Right here. All right, so I only got like 2 or 3 points right there, and then I used symmetry to get the other 2 pedals. All right, real important, use symmetry. So this is all really just a waste of time right there, which I did waste your time on the first video. I apologize, but I just wanted to show you that if you kept going, you're just going to get the same points over and over again. All right, so main thing, get n, and then you're really relying on everything that we knew when we graphed sine and cosine waves.